Today we are going to do some more examples of oxidation numbers in a compound or polyatomic ion. We are going to find out the oxidation number of atoms in them. Let's go through the rules once again. The oxidation number of a free element is always 0. The oxidation number of group 1A alkali elements in a compound is +1. The oxidation number of group 2A element alkaline earth metal family in a compound is +2. The oxidation number of group 7A halogens element in a compound is -1, except when the element is combined with one having a higher electronegativity. The sum of the oxidation number of all the atoms in a neutral compound is 0. 6. The sum of oxidation number in a polyatomic ion is equal to the charge of the ion. Rule 7. The oxidation number of a monoatomic ion equals the charge of the ion. Rule 8. Hydrogen oxidation number is +1 except in metal hydrides such as NaH where it is -1. Number 9. Oxygen oxidation number is -2 except in peroxide where it is -1 and in F2O where it is +2. Rule 10. In either way, a compound or an ion, the more electronegative element is given the negative oxidation number. Now let us do some examples. The first example is of sulfur dioxide, SO2. Here we have to find out the oxidation number of sulfur. OX dot NO here symbolizes, or we can say it's abbreviated for oxidation number. So oxidation number of each oxygen atom equals to -2. If we go to the rules over there in the first two pages, we'll see it is rule number 9. So remember that. Next, what do we see? As there are two oxygen atom, we can see there are two oxygen atom. Therefore, we can write down 2 into -2. This will be equal to -4. Now, in SO2 compound, SO2 has no charge. No charge. So the total oxidation number is 0. This is according to rule 5. If you go back, you'll see it is according to rule 5. Therefore, finally, what do we see? Oxidation number of sulfur will be equal to +4. I hope you understood this. Let's move on to the next example. Example number 2, it's a polyatomic ion nitrate, and it has a negative charge. So here we have to find out the oxidation number of nitrogen. So oxidation number of each oxygen atom equals to -2, -2. So for 3 oxygen atom, we can write down 3 into -2 equals to -6. Now NO3 negative, again what do we see? Has charge of 1 minus. So the total oxidation number of nitrogen and oxygen atom is -1. This is according to the rule 6. If you go back, you'll see it is according to the rule 6. What do we see then? Then the oxidation number of the nitrogen atom plus oxidation number of the 3 oxygen atom, we can write it as -6 equals to here -1. Therefore, oxidation number of nitrogen will be equal to +5. I hope you understood it. Let's go to example number 3. Iodine tetrachloride, ICl3. Here we have to find out the oxidation number of iodine. So let's begin. Chlorine is more electronegative. Electronegative. Then iodine. So chlorine is negative and iodine is positive. Oxidation number of each chlorine atom equals to -1. So for 3 chlorine atom, we can write down 3 into -1 will be equal to -3. In iodine tetrachloride, we also see that it has no charge. So the total oxidation number will be is actually 0. What is the total oxidation number? 0. That is according to rule number 5. Therefore, oxidation number of iodine equal to positive or +3. I hope you understood this. Let's move on to the last example, that is H2S. Here we have to find out the oxidation number of sulfur. So overall, what do we see? It's a neutral compound. Neutral compound. Why is it a neutral compound? Because there is no charge. Therefore, the overall charge is 0. So that is according to the rule, it is 0 because it's a neutral compound. Here what we can do, this is another method that we can use. It's an easy method and it's a much faster method. We don't have to write a lot also. So here overall, what do we see? Hydrogen has an oxidation number of +1 and sulfur we have to find out. So we can put a cross for that. Now we can solve it. 2, that is 2 hydrogen over here, and each hydrogen is +1 and then plus x for sulfur equals to 0. Why 0? Because it has no charge. So what do we see? X equals to -2. Therefore, sulfur has an oxidation number of -2. This is a easier and a much faster method. I hope you have understood it.